Cross-product in direct proportion. As we explained in the previous lesson, a proportion is written in the form shown in the following shown on screen. Or, we obtain the following shown on screen. Where A and B are similar quantities as well as C and D. This is the ratio form of expressing a proportion, where all units are simplified. However, another form of writing a proportion is by expressing it as a rate, i.e. as two fractions where the numerator and denominator of each represent two different quantities. The units cannot be simplified. For example, if 16 tailors can make 40 shirts in one day, then obviously if the number of tailors doubles, 16 times 2 is equal to 32, the number of shirts they can produce doubles too, 40 times 2 is equal to 80. Therefore, if we use the previous notation, we have the following shown on screen. Hence, the two methods of expressing this proportion is shown in the following on screen. I.e. we have the following shown on screen. Or, we obtain the following shown on screen. I.e. we have the following shown on screen. From the two previous methods of expressing a proportion, we can see that A and B can switch their position as well as C and D. And still the proportion is valid. From Chapter 1, we know that the only two operations that possess the commutative property are addition and multiplication. Since ratios are expressed as divisions, which are multiplications by the inverse, we can write the ratio as two products on either side of the expression. Hence, we can write a direct proportion as the following shown on screen. This method of expressing a proportion as equality of products is known as cross-product. Considering the numbers written in the previous example, we can write the following shown on screen. The result in either side is 1280, which confirms the proportion. The cross-product method of writing a proportion allows us to check the veracity of proportion in an easier way without involving rational numbers, simplifications, or GCF calculations. Example. Check the veracity of the following proportions by using cross products. A. 3 to 12 is equal to 7 to 21. B. 20 to 15 is equal to 36 to 27. Solution. A. First, we write the possible proportion in fractional form. We have the following shown on screen. Now, we can write the proportion as cross product. We have the following shown on screen. Since the last equality is not true, it is clear that the original proportion is not true either. B. Again, we write the possible proportion in the fractional form. We have the following shown on screen. Writing the expression as a cross product yields, we have the following shown on screen. Therefore, the original proportion is true. That is all for lesson 4.3.4. To continue this tutorial, please watch 4.3.5, Inverse, Indirect, Proportion. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.